Today's video will explain the collection control loop. Hello, I'm James Helfrich. There are four types of loops: counter control loop, an event control loop, a sentinel control loop, and a collection control loop. Of these, perhaps the most commonly used is a collection control loop. This video will explain the several different variations of a collection control loop and how to use them effectively in a program. So a collection control loop is any loop that iterates through all members of a collection. The types of loops and their exact mechanisms differ greatly from one programming language to another. There are actually 5 types, though. There's an index control loop, where an index or a counter variable iterates through the collection. There's a pointer control loop, where a pointer arithmetic moves through the collection. There's a linked list, where a pointer to a linked list node moves through the collection. There's an iterator, where an iterator moves through the collection. And there's an instance loop, where an instance reference moves through the collection. Let's take a look at each of these in turn. We'll start with an index loop. Arrays can be traversed with an index, starting at the first element, usually element 0, but sometimes like VB is 1, and ending at the last, and usually at length -1. For an example, let's say I want to do this in JavaScript, and I have 5 elements in my score array. So I'm going to use my index variable as I, and usually I or I something, and index is the variable name we use, and I'm going to go from I equals 0, I is less than score of length, I plus. Now with index loops, there are several components. There's the first part is the start condition, in this case, I equals 0. Then we have the end condition, as long as we're less than the size, and in this case, size is score.length. And then my increment, I add 1 to my current value, and then my loop body. And this depends on the application. In this case, I want to say my sum plus equals scores of I. The second type of loop is a pointer control loop, and here I'm going to use pointer arithmetic to move to various elements in memory. Now notice that many languages don't have pointers, but some do, and one of them example is C. So char star P equals text, which is pointer to the first element in text. Star P is going to see if I'm not the null character, and P++ will advance my pointer. So pointer arithmetic assumes we're working with arrays where elements are stored in sequential locations in memory. For an example, if I say software, then text is going to point to the first element, which is S at index 0, and text plus 5 will be pointing to A. And notice, since they're next to each other in memory, I can index to every element by taking my pointer and adding that index to it. So what I could do is I could start it at index 0 or S, and then I'm going to advance my pointer as I walk through the list. So once again, we have 4 parts to the loop. The first part is my start condition, which is P equals text. I'm going to point to the first element in my text. Then my end condition, star P, or P does not equal the null character. I'm going to advance my pointer by 1 by P++. And finally, what is my application? In this case, I want to convert each element to uppercase. Okay, our next type of collection control loop is a linked list. And a linked list is a special type of container where every element in the list is connected to the next through a pointer. So for an example, in C++, node is going to be my one element, my linked list, and I'm going to start at head as long as my P is not the null pointer, and then I'm going to advance it by P equals P arrow P next. So each element in a linked list is called a node, and that's a structure containing both a data element and a pointer to the next element in the sequence. For an example, here I have a 4-element linked list, and P head is going to point to the first element. I'm going to have the values 0, 2, 4, and 6 there. Now I'm going to start with P, and then when I advance the pointer by 1, I'm going to go to the next node. Then I'm going to advance the pointer by 1 and go to the next node, and advance the pointer by 1 and go to the next node. So here we have several different parts of the linked list loop. First of all, the start condition, P equals head, I want to point to the first node in the linked list, the head element. And my end condition, as long as my P is not the null pointer, and usually we indicate the end of a linked list by having P next is the null pointer. And I'm going to increment by P equals P arrow P next. Now P next is going to point to the next node in the linked list, and so P equals P arrow P next is going to point to the next node. So what's my loop body going to be? It's going to depend on the application. In the case of my example here, I'm just displaying the contents. The next type of container control loop is called an iterator. And iterators offer a generic looping structure that works the same regardless of the underlying data structure. And so in Kotlin, for an example, I'll call my iterator it, and it equals scores.iterator. And as long as I have a next element, then I'm going to go to the next one. In C++, I could do the same thing with vector int, : iterator it. So it's a very verbose declaration here, but that it is an iterator variable. And for it equals scores dot begin, it not equals scores dot end, it plus plus, and I'm going to, in this case, sum them up. And then, of course, in Java, I just call it Iterator, and it works exactly the same way. The last type of loop we have is called an instance control loop. And this is the most modern and newest addition to the container control loop family, and most would argue it's the most intuitive way of looping through an array. And here, the instance variable is a reference to an element in the array, and we often call these for each loops. And there's lots and lots of different examples of this. For an example in Java, I would say for int score in scores, and then in VB for each score in scores. And then in C++, I would say auto score in scores. And then Swift, I would say for score in scores. And then in Python, I would say for score in scores. And for JavaScript, I would say for var score in scores. And then C#, I would say score in scores. And finally, in Ruby, I would say score. In each of these cases, we have an example of an instance control loop. Okay, to see how this works, we're going to go through several different looping mechanisms in C++. And the string allows us to do 4 of the 5, so it's a really good example. I'm going to start with an index loop. And I'm going to say for int I equals 0, I is less than s.length, and then I plus plus, and now I'm going to see out. Now, in order to get one element of my list, I'm going to say s of I, and then I'm going to add a space afterwards, okay? For a pointer control loop, it's going to be quite different. For const char star p equals s dot c underscore str, and then I'm going to say as long as p does not equal to the null character, and then I would say p plus plus, and then I would say c out. Now, instead of saying s of I, I'm going to say star p. Okay, so the next one we're going to do is an iterator loop. And so I'm going to say for, now the declaration for an iterator is actually rather lengthy in C++. I got to say string : iterator it, now I should say auto it, but I just want to be verbose about it, equals s dot begin, it not equal s dot end, and then plus plus it. And now I'm going to see out star it. And then my last one will be an instance loop, and I'm going to say for, and this could be const char letter in string, and then I'll say c out letter space. Okay. All right, let's take a look at my loops here to see if it works. I'm going to execute it. And we'll see that I have exactly the same results for each one. Now, let's take a look again that I use an I for index, and then I use a square bracket operator to fetch in a given element. For a pointer loop, I'm using a p for a pointer, and I have to fetch each element with a star p. For an iterator loop, I'm using it, and then I'm using a star it to get my individual element. And from instance loop, well, each instance of a string is a letter, so I'm going to output the letter. You can learn more about collection control loops in the collection controlled section of the loops chapter of the software design textbook.